Hello, everyone. I'm Mark, and I'm from Datastrato. It's a pleasure to be here with you. And what I want to talk about in the next few minutes is how to make maximum use of your AI agents. The typical approach that you'll find from many vendors on the market today is that you deploy your favorite LLM with a selection of MCP tools that they have provided, and you're done. The AI agent has the identity that you as the user have. And so the AI agent can get to everything that you can get to. And if you want it to have more identity, you give it a different identity, and then it can get to everything that that identity provides. And what we want to talk about today is the fact that even though that agent has access to a bunch of tables, that access is not enough in order to guarantee the kind of results that you need. We're from Datastrato, as I mentioned, and we create a tool called Apache Gravitino. Gravitino, I beg your pardon. There we go. Here we go. Gravitino is a centralized catalog that not only provides an Iceberg REST catalog, which you may be familiar with. I may call it an IRC catalog, an Iceberg REST catalog for Iceberg deployments. But Gravitino also specializes in federating other catalogs. You can add to your Iceberg REST catalog a Hive metastore, or a Postgres database, or a MySQL database, or a Kafka stream. And the idea is that you can create an enterprise-wide abstraction of all the data in your enterprise, and you can access it all in a standard way. And since we provide this kind of federation, we have experience with users who are trying to deploy and use AI agents throughout their entire data infrastructure. And I want to share with you some of the problems that we're aware of firsthand that can arise when you start to deploy AI agents. There are three specific problems that I want to talk briefly about, and then the solution that we recommend for solving those problems, which is something called the Agentic Data Protocol. We're actually introducing and releasing the Agentic Data Protocol this week, and I want to tell you a little bit about it. The first problem that users frequently experience is what I call here the semantic loss problem. This is a term I invented. You may know it by different names. So let's talk a little bit about what the semantic loss problem is, and then you'll probably recognize things that you have experienced directly. You know what your data means. You have experience with your tables and their schemas. You know what the units of these tables are and what every column is actually meant to represent. But your AI agent does not. And your AI agent has to infer from the values in those columns or other information what this schema is all about. Many people expect the AI agent to infer based on the title of the schema in the column. And that's fine in very, very simplistic cases, but not in the vast majority of cases. And so we run into four specific issues in the semantic loss problem. The first is that we have structural reasoning errors. Structural reasoning error is what's frequently referred to as a hallucination. The AI product has made the wrong join. It's used the wrong enum values. It has created the wrong logic in your SQL query. And this results in a variety of problems. The second major issue is what I call schema displacement here, and it involves the fact that you have a limited amount of context. Our previous speakers have talked a little bit about context, and it's not used consistently. You have non-deterministic translation problems. Now, what this means is that it would be great if SQL were a highly deterministic language, and that you would always be able to speak something and then turn that into SQL deterministically, which means dependably, the same way all the time. But unfortunately, SQL is not like that. And finally, you have schema staleness, because let's suppose you changed your schema yesterday, and now here it is today, and we end up with the wrong query. Here's an example of what I mean. Almost every query is a multi-step agentic workflow. And so what an agent has to do when you speak an idea is to turn that into a multi-step process and then create a query. This particular query is a 6-step process. And in that 6-step process, I put the example here at the top. Hey, agent, please investigate an account for potential structuring behavior in Q1. Now, structuring behavior is a specific kind of banking thing that, as the previous speaker said, we're not in New York, and we don't have to get into structuring issues, but it's just an interesting problem. Hey, agent, here's a complicated problem, work it out. And as I mentioned, it creates a 6-step process in order to finally materialize this query. What happened? We did have some non-deterministic translation problems because if we would slightly tweak the English in our question, we would get different language. And we may have had schema staleness because our schema evolves all the time. But really the more interesting things, what we can see directly in the query, and I've outlined it in the yellow here, is first of all, there's a structural reasoning error. The join condition is wrong because the AI product joined account ID and customer ID, which is incorrect. And the product has a problem with schema displacement because it used the wrong enum values in order to determine the rows that I'm interested in. Now, I want to show you something I find very, very interesting, and it may be something that you're already familiar with. It's called the lost in the middle problem. The lost in the middle problem is a highly academic and well-documented sort of problem associated with the context buffer. And it was discovered by a couple of computer scientists at Stanford about 3 years ago. You fill your query context with all kinds of information. And in the process of creating a 6-step query plan, your AI agent fills it with more because it has to go out to your database and to your tables and find out what your enum values are and what your schema means, and so context piles up. And not necessarily in this situation, but in any, what these bright people found and documented is that all these products, because of the algorithms that AI agents use, have a tendency to lose things in the middle of the context. The lost in the middle problem. And in a typical AI agent workflow where it's computing queries, what's in the middle here? It's all the schema stuff, because that's what I had to have to get started with this query. What are the schemas of my tables, and what do they all mean? And so there's where the sweet spot is, and there's where we're vulnerable to losing the information we need the most. And so what we need to do is document a better way for the AI agent to collect the information it needs, and then for us to be sure that it uses it. Now let's go on to the second problem. The second major problem is the scope problem. And I bet you have seen the scope problem as well. The scope problem occurs because the AI agent has access to your data. What exactly is the AI agent doing with my data? And our previous speaker spoke about this a little bit as well. The AI agent is doing a variety of things. And there have been documented cases in the past where the AI agent does stuff like persist your data to another disk, or send it to a mail list, or pass it to other AI agents. Is that really what you intended? Probably not. You probably didn't want it to do any of those things. And so we have a double problem because sometimes the product or platform will provide you with a log or something like that to show you what happened. But that's entirely non-helpful here because the data has moved at the time the log occurred. And so the only thing I'm going to get from a log is the fact that, hey, I persisted your disk. I persisted your data to disk. It's over there now. I passed it to another agent. Well, wait a minute, AI. I didn't want my data going over there to begin with. And so we've got a problem. Combined with the fact that in a lot of cases, AI intent is invisible. We don't really know what it's doing, and we can't predict it. In addition, many agents have a volume problem in that we give the AI agent access to a table. It dredges up a query that exposes 350,000 rows from that table and tries to put that huge block of data on the screen. That's what your security people call an exfiltration problem. I didn't really want all my data exposed. I just really didn't. And so, hey, AI agent, you may have access to my data, but please don't show it to a lot of people. Don't correlate it with a lot of stuff that I don't intend. Be extra sensitive about what you do with this. So it would be very tempting to say, as I have shown in the last line here, fine, AI agent, I'm going to instruct you. Okay, so either through a system prompt or through additional context, I'm going to say, hey, Claude, don't persist my data to disk. Don't send it to anybody else. Don't do a variety of things like change it, modify it, create huge blocks. Don't do a bunch of stuff. Now, unfortunately, that doesn't compose to other agents. And so you may be instructing Claude, but what about the next agent that comes around? And you can't instruct all these agents uniformly. And when you add all these instructions to Claude, what did it do with them all? It put them in the context. Where did it put them? In the middle of your context when the 6-step process starts. And we know that we have vulnerability right there due to the well-documented lost in the middle problem. So it's highly possible that we won't even get our instructions obeyed anyway. So we've got a final third problem. And the third problem is called what I like to call the all or nothing problem. Many of you are probably working with an Iceberg data catalog or a database or something like that where you have an RBAC system. And the RBAC system provides you with a variety of privileges, like select and write and, the standard stuff. You get access to a table. And because you give the AI agent an identity, the AI agent has the same RBAC and can do all the same stuff. And that's great, but all these systems grant privileges at the scope of a table, which means that you have no other choice but to give your AI agent the entirety of the table or none of it. And that right there is the source of a huge amount of problems because there's PII in that table and you don't want the agent to get all of it. And so now what? Now we have to decompose our table in order to separate out the PII from the non-PII because I want to grant select on this part and not this part. So we have what I've called here table proliferation. I didn't really want all these tables, but I have to grant access to them in a piece, in an all or nothing fashion. And so I have another choice but to tear them apart. Or I have view sprawl. View sprawl. I'm going to create a view. I'm going to pick out these columns and the agent can have this thing, and then I'm going to pick out these things and it can have that. And so it's another way of dealing with the same all or nothing problem. I don't have enough granularity in my RBAC system to get down to rows and columns, and in order to do that, I have to do this all or nothing, break up my table or create views or something like that. So, 3 serious problems. Now, in the vast majority of cases, if you pick up an Iceberg REST catalog from a variety of vendors, and they will give you a pile of MCP tools, and they'll say, Claude, we've got Claude in the box, go at it. And don't get me wrong, all the LLMs are outstanding. Claude's a fabulous product. I'm not trying to say anything bad about that. And in a lot of cases, this whole scheme is going to work fine. Especially if you're at the demo stage where the vendor shows you a demo. It's like, well, let me show you how well this works. And we're going to run a few queries. And, those are simple. And so they're going to be fine. But when you actually try to put these tools into production on complex enterprise-wide queries, that's where we start to hit the problems. And so what we're proposing in order to solve those problems is something we call the Agentic Data Protocol. And throughout this talk, I may abbreviate it ADP because that's a mouthful to say. ADP is a life cycle for how AI agents communicate with your data platform. They communicate in a very structured, systematic way that takes care of the 3 problems by virtually eliminating non-determinism, scope, creep, all or nothing problems, and most importantly, ADP provides semantic meaning to your data so that the AI agent can dependably determine what the values are and your data really means. Now, ADP has a couple of components. Underneath your AI agent is a client and a server that all the SDKs would speak to, and then your data is underneath. And right now in its present form, it's a JSON 2.0 RPC kind of wire format. But in the future, we've already announced that we're going to make it into a MCP interface. So you can have an MCP tool that exposes each one of the 6 methods that are in ADP. Let's talk about those 6. There's an initialize and a ping step, but basically what your AI agent will do is call discover, describe, validate, and execute. And the meaning of each one of these is amazingly intuitive. Discover allows you to browse available resources. Describe is the workhorse because describe gives semantic meaning to your data. And it's at this opportunity that you have to describe data in a way that the AI agent will be able to read and use and comprehend because it comes at a certain stage in the process where it can't be neglected. Validate is a predetermined step and execute is the execution of your query. So how does ADP deliver the raw goods that make this process go? And the way it does that is that there are 3 manifests in the product where you declare some things that are going to be visible and vital to the LLM or your automatic agent. The first one here is called the physical manifest. The physical manifest is actually about 5 lines of YAML. It's a declaration of what the source is, Postgres, and how do we connect to it. The semantic manifest is the workhorse because this is the thing that's most interesting and unique among all the solutions available today because we're going to give you an opportunity to write down and document a contract between the AI agent and the data source regarding what the meaning of your data is and how much privilege you're giving to the agent to read it. And so we have a fantastic documented contract that the AI agent understands and can follow. And then finally down here in the policy manifest, we have a variety of opportunities to express what we're giving the agent the opportunity to do. You can read, but you can't query. You can write, but you can't change. Now, some RBAC systems will provide for you some of these privileges. I've never seen an RBAC system that provides them all. For example, every RBAC system I know provides a select privilege. I've never seen an RBAC system that will differentiate between a query and a lookup privilege, because a lookup privilege in ADP is the ability to get one row through, let's say, a primary key lookup. A select is the same as a query in ADP, which is the ability to query all the rows in my table. So right there, we've differentiated a finer grain of permission, and we can differentiate what it is that we really want to give the LLM the ability to do. And similarly for write. Now, let's look at these manifests in action. Here's the semantic manifest. I gave you 4 daunting problems for what a semantic scope problem consists of. I said we have structural reasoning errors. The join key was wrong. We have an actual example of when the LLM agent produced the wrong join key. This is eliminated in this situation because the business asset that you've identified to ADP has a join key built in. The LLM doesn't infer the join key anymore because you've set it up. The second problem is schema displacement. You remember the lost in the middle thing. LLMs, by definition, and every single one of them has this problem today, loses stuff in the middle. It's just the way these algorithms work. But this is eliminated here because ADP Describe provides schema information exactly when the LLM needs it. It's at the top of the stack. So it's no longer part of a sea of context. The typical answer that some people have tried to adopt is, well, I'll just make the context bigger. I think Claude currently provides a context of like 400 million characters or 400 million tokens, or it's staggeringly large, which doesn't in any way substitute the actual nature of the problem because the middle context is still vulnerable. The third major problem here is non-deterministic translation. And the determinism in ADP is extremely high because the number of verbs that it exposes are very small and the surface area is very limited. And then finally, schema staleness, but the semantic contract always provides the correct schema. Now we've got the policy manifest. That was the third of the 3 manifests in ADP. There are 4 different access policies in ADP, and we started to talk about these a minute ago. Lookup versus query, ingest versus revise, and then we have some additional horsepower here to indicate when we have to have a mandatory filter or when we have to have certain operational policies. You know, one thing that is absolutely great about ADP that I like is that there are many situations in which I just don't want the LLM to perform a query in which it doesn't also filter by date. It's like, do not try to bring up the entire table here. You must filter by date. This provides enforcement to do that. All right, so ADP, wow, how great. A couple of things that I want to show you is that we are committing to an ADP product roadmap. We're introducing the concept here, and we have open sourced the ADP initial protocol, the server, and the client. And so if you're so interested, you can go to the URLs that I'll give you in a minute, and you could build some stuff. I mean, I would love to assist you with that. In addition, we are committing to a roadmap here that includes a couple of things. I've said that the semantic manifest is the workhorse. Well, where do I get all this semantic information? We are creating now a semantic manifest generator that will use the LLM to create the contract based on all kinds of stuff that you have, including your current policies and everything else. And so you're going to see a semantic manifest generator that will make the policy concrete. And then I already mentioned we're putting in MCP tool interface on it. And so you're going to see here that ADP provides a number of benefits over raw MCP. Raw MCP has no semantic information about anything. MCP provides a tool that the LLM has to read in order to see which ones to call first and in what order. There's no guarantee it's going to do that. There's no guarantee that it's going to help it with any of the problems that we've talked about. MCP has no policy layer, and MCP has no agent lifecycle. The agent can still do whatever it wants. And so we think that this is really a complement to MCP that's going to add some much needed structure. So, as my final slide here, I want to invite you to participate. We have released all the ADP source code, and I show here the GitHub for how you can get the ADP hypervisor or the ADP protocol, and you can start building your own stuff, and I would love to help you. Now, I actually have a demo that's very simple on my laptop, and unfortunately, I didn't have time during this pitch to show it. But if you want to contact me later, I'll meet you later, or later on tonight. I don't know how long you're going to stay or how many how much time you have. But I would love to show you on another occasion or at a time that suits you. We'll go through a little demo, or I'd love to assist you. If you want to open the tool and take a look at it, that would be great. Or join the conversation, because ADP is now open source. Any other questions before I go? Thank you very much.